All right, welcome everyone. So this is run length encoding. We got Gabriel on the line. And so we're going to take a string sequence. So we have here in the example, they give us let's just look at the tests. I always rather look at the tests. Okay, so we have A, B, C, a bunch of X's, and Y. So the way this works is we have a number and then a letter. And if there's no number, then we just assume that the letter is once. So there's no way to have like sequences of two, like you can't say A, B, A, B, A, B, A, B. But, so we have 3 A's, B, 2 C's, 6 X's, and a Y. That's how you read that. And you can also go the other direction. So we have, this is called run length encoding. So run length decoding would be taking in that same sequence and returning back what we got from the input. So we have string manipulation on our hands, basically. So I don't know, Gabriel, what do you think? How would you start approaching something like this?
Yeah, so this challenge seems definitely challenging. So I guess I would.
And I have it's very long. I don't want to interrupt you. It's very long, so I'm happy to show you a solution. By the way, you're not on the hook for it, but yeah, tell us what you think.
Yeah. So so obviously we need to go through these strings letter by letter, and we need to kind of accumulate the number of like the same letters in a row. So it means that we can. So one way to do that would be to so we can use like template literal types and extract the first letter and the rest of the string, and we keep some kind of accumulator array. And while the current letter is the same as the letter in the previous group, we just put that in the same like sub array. So we would have a function that returns basically an array of arrays. And at the end of this function, we get this array of arrays, and we transform this array of arrays into an array. Like we can actually just serialize the string right away. We have the length of the tuple, so we can read the length of this tuple using tuple square bracket length, and so this gives us the number that we need to concatenate to the letter, and we can pick any letter in the array to display it, and I think that would work. What do you think?
Yeah, that would work. It's very. I'm looking at solutions. They're very long. We could try it if you like. I would rather show you a solution, but sometimes people get angry at me if I just show people solutions. But how about? Yeah. How about I'll show you one, and then we can try to pick it apart, and we'll look at. I have 2 prepared, so we'll see how it compares to what you suggested. So. I don't know. How about this? Could you walk us through it? Like read us through it and help us understand how this works. I know how it works because I prepared, but like maybe that would be a fun thing.
Yeah, sure. So let's start with encode with the first one. So we have this namespace. So we are just going to look at this thing. Okay. So yeah. So first, there is this idea of accumulating things with this accumulator string and the count here. So those are arguments with default values. So it's very common when you have a recursive function, you just add a bunch of optional parameters that are not supposed to be passed when you call the function, but you are going to set them to. It's basically how we keep some local state or like accumulate over time some information in functional programming. So we have count. So what is exactly? I don't know yet. So
I'll tell people there's a funny thing, like in the challenges, it's been like a little running joke that usually I'll put for counters, some people will put like 1 here because usually we're just counting like a number of things and we don't care what the values are inside. But I'll note that we're not doing that here. We're using string array. So we're actually looking at the value inside of the counter. As well as, I guess we're not looking at the length of it at all. So it's kind of interesting.
Yeah. So so it looks like this count thing is like contains the previous letter.
Mm-hmm.
So initially it's empty. So count of 0 extends add or undefined. So this is going to evaluate to undefined initially. So it means that we'll be taking this branch, and then we put head in our count thing. So this is the translator basically,
Mm-hmm.
and it's so it's like a reversed array apparently, because we add count after
At
head.
the end. Yeah.
In order to always read. Yeah, I guess that makes sense, because you always want to read the first element. Okay, and this ag string.
The accumulator.
Yeah. So how is it set? So yeah. So if the letter is different, then we pick this branch. So we reset the count.
Mm-hmm. And we pack in. That's where it's set. I think. We throw in the accumulator up to that point.
Yeah. And so run length.
And then we jump up to run length. Yeah.
Yeah.
Let's
So
go
this
see
is
it.
interesting. Okay. So yeah, that's kind of weird. So if the length is 0 or 1, then we return an empty string. Otherwise, we return the content of length. So this returns either like a string number or just an empty string. Oh yeah, I see why. Okay, it's just because we want to we don't want to display a number if it's 0 or 1. Like 0 seems like a case
Yes.
that can't really exist, but we don't want to display 1A, for instance. We want to just display A.
Mm-hmm.
So that's why. So this is the serialized string,
Yep.
and we just repeat the same the same thing
Yeah.
when we reach the end of the string.
Yep, it's exactly the same down there. That part.
Yeah. So it's similar to what I was suggesting, but it's like everything is done in a single iteration. So that might be a little bit more efficient.
Yeah, it's definitely a nice solution. And then we have decode. I think we didn't hit repeat string yet, so we have repeat string here. Let's look at decode.
Cool. So decode. So yeah. So in this case, we are going through the string 2 letters by 2 letters. So we pick the first and second letter and the rest. And yeah, so if the first letter is a number, so that's how you check if a string contains a number. That's a pretty cool feature that has been added fairly recently. So you can use this extend constraints on an infer variable. So we know that the first letter is a number in this case. So it means that we need to, since we are decoding, we need to repeat the letter, which is this B variable in this B variable n times, and so we do that with this repeat string function, which we can jump to. So how does that work? Okay, so we are just using counts as basically a way to stop us from recursing indefinitely, it seems. So count is an empty array, and it's basically our iterator, and we are just going to increase its length every time. We push something in it every time in order to stop when the length of after n iteration, basically. So when the length of our count thing reaches n. In this case, we return the accumulator, and this accumulator we just add the letter at the end of it every time. So it's pretty straightforward.
Yeah. So if you could, is there anything you think you would improve about this, or is it good as is?
Well, I think it's pretty good. I don't think I would have implemented it that way. I think I would have preferred like splitting the logic into like several steps rather than trying to do everything in a single iteration.
In one go, yeah.
No.
It's hard to know sometimes. I'm also a pretty big fan of usually putting things in like separate chunks like that, but it's a little complicated. I also wanted to show, I prepared a little thing for this one to show people what happens when you put 3 things here. So I made a little type here that does basically the same thing, and it just wraps them in an object so we can see all of the values. And I put XYZ. So I think it's pretty clear that that's what would happen for XYZ. If we have XY, C will be an empty string. which is similar to what happens with arrays. If you do this same sort of inferencing with arrays, the last thing will be an empty tuple. If I just put X, then we're completely out. There's nothing to match on. We hit the false branch. But X, Y, Z, 1, 2, 3. Let's do that. So what we see is we grab the first character and then the second character, and then always at the end is just all of the rest. So that's what's happening here, is grabbing the first two characters, if there are two. And if there are none, then the last one will be an empty string anyway. But I just thought I would show that
that's a good idea.
thing. And then I have one more to show, and maybe you can tell me if you like this one better. I don't think you will, though, because it's even more inlined. Let's comment out this top solution from drylint. Cool. So I don't know. First glance, what do you think? Too much? I think it's a lot. It's a lot on the screen at once.
It's definitely hard to pass, but let's try. So so maybe we can start with the base cases. So this is the initial case, actually. Whoa. This one is pretty complex. So I need to understand what this prev thing is.
I think it's like the accumulator. I probably should have named it accumulator.
So, but what do we put in it? So we just...
Is it an array of arrays, like prev?
It's an array of strings. And
yes.
And so it contains, so basically it contains the previous string, like the previous string, and use the length of this array to know how many times it appeared. And if the letter, the current letter we are on is different from prev.0, we reset it, I would imagine. But I'm trying to read this, which is
it's hard to fit it on the screen. So this is like a string with 3 sections. This is the first section, third section, second section, and then third section. So I think this is like if there's nothing here to grab.
So we are serializing the string here. So this is our return value, and we recurse inside of it. So we take the current number. If it's different from 1, then we put it in the string. Otherwise, we put an empty string, and then the letter, and then the rest.
Hover over encode. Do you see that?
No. What?
Right here. Hover over this one. I love this when this happens.
Like TypeScript is trying to inline everything, and it's a giant expression that's
good times. I think it seems pretty similar approach. We can go a little faster, I suppose, on the decode. Looking at the decode, we don't have to pick apart every piece of this, but it does take use of that extends number functionality, which is like you said, it's new and pretty exciting to be able to do that, because if you look at solutions of how that same job was done in the past, it was very messy to do before. Now it's much simpler. So what do you think about this one?
So now count. Well, I think it does look pretty complex as well, but it's definitely manageable. So we just need to try to look at branches independently. So if the head is a number, what do? We wait. If it is a number, we decode. But num, what is num? So num is
the string that we're repeating.
Okay.
I think.
Okay, yeah, that makes sense. So it's that's confusing because it's actually not the number; it's like the letter.
The letter, yeah.
Okay, so that's the current letter. So if it's wait, oh no, this is the thing that we're constructing. Is it our
So for decode, let's look at a test. So for decode, we get in a string that has the numbers in it, and we spit out letters.
Yeah.
So I think we only ever get this function only ever takes one argument. So the rest of it is just temporary storage.
Yeah.
So let's see a usage. So like this is passing in when we look at where we recurse, when we have a second argument, we have one here and we have one here. This is the two places that num is being set. And it's being set to, well, in the first iteration, it would be nothing with the value of the head. So like the number of times that we're recursing. So I think it's this first block here is just handling the very first recursion case. Or I guess also situations where there is no number, because that's also valid in this syntax that you could just put, like we saw. Let's go up and look. You could just say, what is it, B. So there's no, it doesn't say 0B or 1B, it just says B. Right. Okie dokie. So this one doesn't handle 0. I like that the other one handled like what happens if there's a 0, but this one doesn't. So in any case, so this is handling that first recursion case, and then it's saying, okay, now that we have an actual number in there because we've recursed already more than once, now we can do our work. It's like a generator. It has like a little state machine inside here.
Yeah.
And then from there, we have the number of times that we need to recurse because we have our count length, and we can go, keep going. And if we need to increase our counter to recurse again, then we will, and then recurse again. But if not, then we can just spit it out.
That makes sense.
No need to keep going. Yeah.
Wow.
This is a tough one.
This is really scary. I would say like this type of code. It's the first time you look at types and like you're trying to run TypeScript. This could maybe discourage you from doing so. But
I'll say one compliment about it. It's made by this guy teamchong on GitHub, and one thing I like about this person is there's only about 8 or 10 people maybe that have solved all of the challenges. I'm not one of them. I just I'm not good enough to do this like at that caliber. But this teamchong person put through solutions for every challenge, and they're very often the most distinct. Like when I see a solution from him, I go look at it, because he definitely doesn't look at other people's solutions before solving them, because sometimes there'll be 10 solutions, 9 of them taking one approach and then his taking a different approach. And it's not always the best approach, but it's at least interesting. So.
Yeah, it's definitely interesting. Also, it's very, very smart. I'm not saying that this is bad or anything like that. It's definitely smart, and I'm sure it does the job perfectly. But it's kind of hard to read if you're not used to that style.
The good news is you should probably never have to actually do this. So it's just a learning exercise, But cool, we can keep going. Let's go on to the next one.